Hi everyone, today we're going to learn the lesson 13.2 exponential decay functions, and we will be writing equations in this format for an exponential decay function, and you will be doing the try me problems that are given in the examples. So let's take a look at the review right here. What we already know is that this is the parent function, f of x equals b to the x, and then this is the general equations that are caused by the transformation. So these are the reference points here. And these are the equations that we will use to help us find A and B in our equations. So here is the first example. Write an exponential function that will produce the given graph. State the domain and the range. So we're taking a look at the equation. There are 2 points that are already identified, this one here and this one here. And as stated before, the one that is closest to the asymptote here, we will use that point to identify our h. So we know based on this, h is equal to 2. And k is actually the same thing as the asymptote. So k is equal to -1 in this case. And so let's write down our information. We have h equals 2, k equals -1. And the other graph, the other point is x and y. So we have x equals 1 and y equals 4. And using the equations that we have from here, we know that we can help solve for a little differently than the last lesson with exponential growth. So since we know that this point is mapping up to the 0, 1, and that is the point, the reference point that is closest to the asymptote. So the point 0, 1 is now closest to this point right here. So in this case, we are going to set this point right here equal to a plus k. So we have the equation a plus k is equal to -1/2, since it maps up to the same coordinate. And since we already know k, we're going to substitute -1 in, and adding 1 to both sides will yield a equals 1/2. So we have 1/2. Using the second point, the same position here, we are mapping up the point to this equation here, a over b plus k. So we're going to let that equal to a over b plus k. And this one is the point that we have a plus k. So using the same equation, we have a over b plus k. We already know. So let's go ahead and let me just finish the equation, and then we're going to have 4. So that point is mapping up to 4. We already know a is 1/2. We do not know b. We know k is -1. So after substituting those values in, we will solve for b. So let's add 1 to both sides first, and we have 1/2 over b is equal to 5. We can cross multiply, and we have 5b is equal to 1/2. Dividing by 5 is the same as multiplying by 1/5. So we're going to multiply that and we'll cancel it out. We have b is exactly 1/10. So we have found that b equals 1/10 and a is equal to 1/2. And we can now proceed with writing the equation. So we have an equation, g of x is equal to a, which is 1/2 that we found, b is 1/10, x minus h, that's going to be x minus 2, and then finally k is -1, and this is the final equation that produced the original graph. And you can go ahead and use decimals and substitute this equation in there to verify that we have the same equation. And just want to also point out that again we have the horizontal asymptote of -1 right there. And let's go ahead and try one. So you can pause the video at this point and try this problem to make sure that you know what to do, or you have tried the problem before you look at the answer. And now that you have tried the problem, let's go ahead and look at how it is done. We have the 2 points that are identified are 0, 4, and 1, negative 2. So again, the point that is closest to the asymptote is going to have h of 1, and then we have k is negative 4. So we have h equals 1, k equals negative 4, and then the other point is x and y. So we have x equals 0, y equals 4. And then let's go ahead and again map up this first point to a plus k. So we have a plus k equals negative 2. And since we already know k equals negative 4, we're going to substitute negative 4 inside for k. And we have a equals 2. And the next thing we're going to do is let the second number here equal to the equation a over b plus k from the general equation. So we got a over b plus k equals 4. And let's substitute the 2 inside. We already know that is 2. A equals 2. And k is negative 4. We're going to add 4 to both sides. We have 2 over b equals 8. Cross multiplying, we have 8b equals 2. Therefore, b equals 2 over 8, or 1/4. So now we have solved for a and b. We can go ahead and substitute that into the final equation, which will give us g of x is equal to a, which is 2, times b, which is 1/4, to the x minus h is 1, so it's minus 1, and then with a minus 4 in the back, and that will be our final equation for this graph. You can again go ahead and use decimal to verify to make sure that is in fact the equation. Next, we're going to take a look at some real-world situations dealing with exponential decay function. So this is the general equation for an exponential decay. A represents the initial value, R is the ratio, and t is the time and then we also call this 1 minus r the decay factor. That is the factor that we are being reduced by. And so let's take a look at this example. And the value of an equipment is 30,000 and decreases at a rate of 16% per year. And we're going to write the function f of n that expresses the value of the equipment after n years. So we do know that the ratio is 0.16 for 16%, and the initial value is 30,000. So we're going to start with the f of n equals the equation from here, which is a times 1 minus r to the t. And substituting our initial value of 30,000 in, and the ratio is 0.16 to the t, and reducing the 1 minus 0.16, which is 30,000 times 0.84 to the t. Notice that means we're actually losing value because we're growing at a 0.84. That means every year it's only going to come back at a rate the value at 84% of the previous year. So the next question is find the value of the equipment in year 8. So we're looking for f of 8, which means we're just going to substitute 8 into the function. So go ahead and use your calculator to verify. I have 7,436.28 cents, and that would be the value of 30,000 equipment in 8 years. Next problem, we're going to take a look at the computer value. Supposedly, the computer value at 2765 depreciates at a rate of 30%, so that's a big loss for computer equipment. Use a graphing calculator to determine the number of years it will take for the computer's value to be 350. So let's begin by writing f of t using the same model, a times 1 minus r to the t. Initial value is 2765 times 0.7 to the t power. And then we want that value, since the ratio is 30%, so that would be a 0.3. So 1 minus 0.3 is how I got the 0.7. Okay, that is, and then we want to know when the value is going to be 350. So we're going to set it equal to 350. So on the graphing calculator, we're going to enter the equation on decimals. So go ahead and log into your decimals program and make sure you're following along when you're doing this. And the first equation we have is, we're going to just enter the left hand side. So 350, that should be pretty big number, so we need to zoom it in so we can see that y equals 350. So you should have a straight line. Next, we have the right hand side, we're going to enter it as y equals 2765. I forgot the equal sign. So y equals 2765 times 0.7 to the x power. So there's my second equation, and you can see that this is a decay function. It's going down. And so we're going to zoom in and see where do they meet. So I'm going to tap, and that is exactly going to be at 5.795. So we can see that that is where the two equations meet. So we know that the answer is about 5.8 years. So let's go back to our lesson here. And so we know that t, according to the graphing calculator, is about 5.8 years for the value to be at $350. And let's take a look at the next one, the famous car depreciation problem. So we all know that cars, equipment, anything like that, once you buy it, it's going to lose value. So this car is losing value at 20% each year. Miguel argued that the value of the car after 5 years must be 0, since 20% times 5 equals 100%. So do you agree or disagree? So you can think about it and then answer the question before you move on. Pause the video. So Miguel is actually wrong, because that is not how math works here. So if we look at using the same model, the function that we have, a1 minus 0. The ratio is 0.2 to the t, and we don't know how much the car starts to cost, but we're just going to leave it a, and it's 0.8, which means every year the value of the car is going to come back at 80%. So we're going to look at the first year when t equals 1. That means it's going to be 0.8 times a, which is 0.8a. That's a minus 20%. Next year, it's going to come back at a times 0.8 to the second power, and that's going to be 0.64. That means it's only coming back at 64%. So you're losing 36% in year 2. And if you keep going, f of 3, that's going to be a times 0.8 to the third. That's going to be 0.512, or you're going to be losing 48.8%. And keep going, f of 4 is going to give you a times 0.8 to the fourth, which means 0.4096a, or you're losing 59.4%. And in year 5, you will actually be losing about 67.232%. So it is not losing the entire 100% as Miguel claims. Okay, so Miguel is wrong. And that would be a wrap for this lesson. And don't forget to do homework. It's going to be the book set, finish your HRW, copy notes for 13.3 day 1, and don't forget Alex. Have a great day.